The Lasting Effects of the Scientific Revolution by Josh Carey, Ryan Flynn, and Nicholas St. Laurent.
Although one of the greatest scientists of the modern era, Isaac Newton was quite an eccentric person, sometimes locking himself up for 22 hours a day working on equations. Although most known for his work with mathematics, Isaac Newton also discovered the law of refraction, in which he discovered that white light is composed of multiple colors. In a famous experiment, Newton showed one beam of light through his window into a prism and split it into multiple colors, something that had never been replicated before. Isaac Newton also invented a new type of telescope, a reflecting telescope, in which the light is reflected from a central mirror into the eye. Isaac Newton's greatest accomplishments were in mathematics, where he invented the binomial theorem and formulated a universal theory of gravitation. Newton's theory states that the force of gravity is proportional to the product of the two masses and inversely proportional to the square of the distance between them. Though this may sound complicated, it's quite simple and allowed astronomers to finally grasp why the planets move around the sun in the way they do. Isaac Newton's contributions to science have led us to be able to predict the motions of objects incredibly precisely, allowing us to predict where a baseball will go in a baseball game, and to be able to send men to the moon. René Descartes was a 16th century philosopher and mathematician living in France. He made astounding contributions to mathematics and philosophy. Descartes' greatest mathematical contribution was analytic geometry. Descartes' method combined algebra and geometry and allowed geometric shapes to be graphed easily and correctly. Descartes also formulated the idea of mind-body dualism, in which the mind is a separate, immaterial thing from the body. Descartes thought that the planets moved around the sun in a vortex, meaning that they all swirled around the sun. Though the theory ended up being wrong, it held intellectual sway in Europe for over 100 years.
Another influential character in the 15th and 16th century was Nicholas Copernicus. Not only was he known for his work with mathematics and being a physician, he was most famously known for being a Polish astronomer. The accepted model of the solar system at the time was a geocentric model. This is where Earth was at the center of the solar system and it was the single body of motion. Copernicus firmly disagreed with the geocentric model. Instead, he came up with the heliocentric model, which was based off of observation and mathematics. Copernicus's book displayed his observations and mathematical equations to prove the heliocentric model. This book was not published until he was on his deathbed because he was afraid to anger the Catholic Church. Born in 1564, Galileo Galilei became one of the most influential men in all of scientific history. He was known for his work of proving the heliocentric model and changing the Church's views. In 1609, Galileo was the first to make important observations with the use of a refracting telescope. This telescope was made by his own hands and it was far superior to all other telescopes. After he was done observing the moon, Galileo moved on to the second brightest thing in the sky, Jupiter. He noticed that Jupiter had 4 distinct stars following around it. He didn't know what it was until he continued to look after it. He soon realized that the bodies following Jupiter were planetary bodies, much like our moons. He discovered that they were actually moons of Jupiter. Discovering that Jupiter had moons surrounding it, Galileo knew that Jupiter was a center of motion, same as Earth. This meant that there could be multiple center of motions in the solar system, and since the Sun was the largest, it meant that it was the largest center of motion, which could pull all objects into orbit around it. This correctly proved the heliocentric model and disproved geocentricity. Not only did Copernicus and Galileo change the views of the Catholic Church, it changed the views of the world and made us think differently and how we still believe today how the Earth is revolving around the sun.
Anton van Leeuwenhoek was a Dutch linen draper that owned a small shop and lived with his family. He curiously started to fiddle with small glass lenses, using them to magnify small objects in order to see them better. Leeuwenhoek's simple magnifying glasses were nothing more than single biconvex lenses mounted between two metal plates. They could magnify objects up to 200 times. During his career, he used his microscopes to observe samples of bacteria, red blood cells, spermatozoa, microorganisms from lake water, and parasitic protozoa. All of Leeuwenhoek's work and observations with his simple lenses allow modern scientists to use their complex microscopes on a regular basis today. Another important figure during the scientific revolution was a man named Andreas Vesalius. He was a well-known Flemish physician that had a strong interest in how the human body was structured. Vesalius focused most of his career to dissecting human corpses and noting his observations. He discovered many new things about skeletal structure and muscles. One thing that he was most famous for was discovering the many errors that a Greek physician named Galen had made when he wrote about the human body. Although his views came under attack by the Catholic Church, his colleagues, and a large portion of society, he has affected our lives by introducing the new concepts about the human body that most of today's medical knowledge is based on. One last crucial figure from the scientific era was an English physician named Edward Jenner. He was the first person to successfully find a vaccination for the disease smallpox. Smallpox was a major deadly disease in England for a long period of time. The virus caused a painful rash of blisters to cover the body and led to horrible scarring if the victim survived. Jenner had heard theories that those who had a similar but less deadly disease called cowpox couldn't get smallpox. Jenner put this theory to the test when he injected matter from the blister of a milkmaid with cowpox into an 8-year-old boy. Weeks later, after the boy was healthy again, Jenner exposed him to the smallpox virus. Amazingly enough, the boy didn't catch the disease. Edward Jenner had just successfully created the first vaccination for a deadly disease. His simple and risky experiment would forever change mankind's struggle against disease. All of these men and their remarkable contributions to science, astronomy, physics, and medicine helped push humanity through the scientific revolution and stimulated advanced ways of learning for the future.